Network attacks today. Distributed denial of services, or DDoS. This is a coordinated attack from many devices, called zombies, with the intention of degrading or halting public access to an organization's website and resources. Data breach. This is an attack in which an organization's data servers or hosts are compromised to steal confidential information. Malware. This is an attack in which an organization's hosts are infected with malicious software that cause a variety of problems. Network security devices. Various network security devices are required to protect the network perimeter from outside access. Endpoint protection. LAN devices such as switches, wireless LAN controllers, and other access point devices interconnect endpoints. Most of these devices are susceptible to the LAN-related attacks that are covered in this module. Cisco Email Security Appliance. Content security appliances include fine-grained control over email and web browsing for an organization's users. Block known threats remediate against stealth malware that evaded initial detection, discard emails with bad links, block access to newly infected sites, encrypt content in outgoing email to prevent data loss. Cisco Web Security Appliance. The Cisco Web Security Appliance is a mitigation technology for web-based threats. It helps organizations address the challenges of securing and controlling web traffic. The Cisco WSA combines advanced malware protection, application visibility and control, acceptable use of policy controls, and reporting. Authentication with local password. Many types of authentication can be performed on networking devices, and each method offers varying levels of security. A better solution is to have all devices refers to the same database of users and passwords from a central server. AAA components. AAA stands for authentication, authorization, and accounting. The AAA concept is similar to using a credit card. The credit card identifies who can use it, how much that user can spend, and keeps an account of what items or services the user purchased. Authentication. Local AAA stores usernames and passwords locally in a network device such as the Cisco router. Users authenticate against the local database as shown in figure. Local AAA is ideal for small networks. Authorization. AAA authorization is automatic and does not require users to perform additional steps after authentication. Authorization governs what users can and cannot do on the network after they are authenticated. Accounting. AAA accounting collects and reports usage data. This data can be used for such purposes as auditing or billing. The collected data might include the start and stop connection times, executed commands, number of packets, and number of bytes. 802.1x. The IEEE A02.1x standard is a port-based access control and authentication protocol. This protocol restricts unauthorized workstations from connecting to a LAN through publicly accessible switch ports. The authentication server authenticates each workstation that is connected to a switch port before making available any services offered by the switch or the LAN. Step to mitigate VLAN hopping attacks. Step 1. Disable DTP, auto-trunking, negotiations, or non-trunking ports by using the switch port mode access interface configuration command. Step 2. Disable unused ports and put them in an unused VLAN. Step 3. Manually enable the trunk link on a trunking port by using the switch port mode trunk command. Step 4. Disable DTP, auto-trunking. Negotiations on trunking ports by using the switch port non-negotiable command. Step 5. Set the native VLAN to a VLAN other than VLAN 1 by using the switch port trunk native VLAN number command. DHCP snooping. DHCP snooping does not rely on source MAC addresses. Instead, DHCP snooping determines whether DHCP messages are from an administratively configured trusted or untrusted source. It then filters DHCP messages and rate limits DHCP traffic from untrusted sources. Step to implement DHCP snooping. Step 1. Enable DHCP snooping by using the IP DHCP snooping global configuration command. Step 2. On trusted ports, use the IP DHCP snooping trust interface configuration command. Step 3. Limit the number of DHCP discovery messages that can be received per second on untrusted ports by using the IP DHCP snooping limit rate interface configuration command. Step 4. Enable DHCP snooping by VLAN or by a range of VLANs by using the IP DHCP snooping VLAN global configuration command. Dynamic ARP inspection. In a typically ARP attack, a threat actor can send unsolicited ARP replies to other hosts on the subnet with the MAC address of the threat actor and the IP address of the default gateway. To prevent ARP spoofing and the resulting ARP poisoning, a switch must ensure that only valid ARP requests and replies are relayed. DAI implementation guidelines. To mitigate the chances of ARP spoofing and ARP poisoning, follow this implementation guidelines. Enable DHCP snooping globally. Enable DHCP snooping on selected VLANs. Enable DAI on selected VLANs. Configure trusted interfaces for DHCP snooping and ARP inspection. DAI example. Destination MAC. Check the destination MAC address in the Ethernet header against the target MAC address in ARP body. Source MAC. Checks the source MAC address in the Ethernet header against the sender MAC address in the ARP body. IP address. Checks the ARP body for invalid and unexpected IP addresses including addresses 0000, 255, 255, 255, 255, and all IP multicast addresses. 802.11 Frame structure. Frame control. This identifies the type of wireless frame and contains subfield for protocol versions, frame type, address type, power management, and security settings. Duration. This is typically used to indicate the remaining duration needed to receive the next frame transmission. This is usually contained the MAC address of the receiving wireless device or AP. Address 2. This is usually contains the MAC address of the transmitting wireless device or AP. Address 3. This sometimes contains the MAC address of the destination, such as the router interface to which the AP is attached. Sequence control. This contains information to control sequencing and fragmented frames. Address 4. This usually missing because it is used only in ADHOC mode. Payload. This contains the data for transmission. FCS. This is used for layer 2 error control. CSMA or CA. WLANs are half duplex. Shared media configurations. Half duplex means that only one client can transmit or receive at any given moment. Shared media means that wireless clients can all transmit and receive on the same radio channel. This creates a problem because a wireless client cannot hear while it is sending, which makes it impossible to detect a collision. Wireless Client and AP Association SSID. The SSID name appears in the list of the available wireless networks on a client. In larger organizations that use multiple VLANs to segment traffic, each SSID is mapped to one VLAN, depending on the network configuration. Several APs on a network can share a common SSID. Password. This is required for the wireless clients to authenticate to the AP network mode. This refers to the 802.11a, b, g, and ac or AD WLAN standards. APS and wireless routers can operate in a mixed up, meaning that they can simultaneously support clients connecting via multi-standards. Security mode. This refers to the security parameters settings such as WEP, WPA, or WPA2. Always enable the highest security level supported. This refers channel settings. This refers to the frequency bands used to transmit wireless data. Wireless routers and APs can scan the radio frequency channels and automatically select an appropriate channel settings. The channel can also be set manually if there is the interference with another AP or wireless device. Passive and active discover mode. In active passive mode, the AP openly advertises its server by periodically sending broadcast beacon frames containing the SSID, supported standards, and security settings. In active mode, wireless clients must know the name of the SSID. The wireless client initiates the process by broadcasting a probe request frame on multiple channels. Split MAC architecture. A key component of CAP-WAP is the concept of a split media access control. The CAP-WAP split MAC concept does all the functions normally performed by individual APs and distributed them between two functional components. AP MAC functions. Beacon and probe responses, packet acknowledgements, and retransmissions, frame queuing, and packet prioritization, MAC layer, data encryption and decryption. WLC MAC functions. Authentication, association, and reassociation of roaming clients. Frame translation to other protocols. Termination of 802.11 traffic on a wired interface. DTLS encryption. DTLS is a protocol which provides security between the AP and the WLC. It allows them to communicate using encryption and prevents eavesdropping or tampering. Flex Connect APs. There are two modes of operation for the Flex Connect AP. Connected mode. The WLC is reachable. In this mode, the Flex Connect AP has CAP-WAP connectivity with its WLC and can send traffic through the CAP-WAP tunnel. As shown, the WLC performs all its CAP-WAP functions. standalone mode. The WLC is unreachable. The Flex Connect has lost or failed to establish CAPWAP connectivity with its WLC. In this mode, a Flex Connect AP can assume some of the WLC functions such as switching client data traffic locally and performing client authentication locally. Advanced setting. Most WLC will come with some basic settings and menus that users can quickly access to implement a variety of common configurations. However, as a network administrator, you will typically access the advanced settings. For the Cisco 3504 wireless controller, click Advanced in the upper right-hand corner to access the Advanced Summary page as shown. From here, you can access all the features of the WLC. Configure a WLAN. Wireless LAN controllers have ports and interfaces. Ports are the sockets for the physical connections to the wired network. They resemble switch ports. Interfaces are virtual. They are created in software and very similar to VLAN interfaces. In fact, each interface will carry traffic from a WLAN is configured on the WLC as a different VLAN. The Cisco 3504 WLC can support 150 access points and 4096 VLANs. However, it only has 5 physical ports. This means that each physical port can support many APs and WLANs. The ports on the WLC are essentially trunk ports that carry traffic multiple VLANs to a switch port distribution to multiple APs. Each AP can support multiple WLANs. SNMP and radius. SNMP is used to monitor the network. The network administrator wants the WLC to forward all SNMP log messages, called traps, to the SNMP server. The credentials will be verified by the radius server. This way, individual user access can be tracked and audited if necessary. If user accounts can be added or modified from a central location, the radius server is required for WLANs that are using WPA2 enterprise authentication. Configure SNMP server information. Click the Management tab to access a variety of management features. SNMP is listed at the top of the menu on the left. Click SNMP to expand the submenus. Then click Trap Receivers. Click New to configure a new SNMP trap receiver. Enter the SNMP community name and the IP address. For the SNMP server, click Apply. The WLC will now forward SNMP log messages to the SNMP server. Configure radius server information. Click the Security tab, then Radius, then Authentication. No radius server are currently configured. Click New to add PCA as the radius server. Click New. Enter the IPv4 address for PCA and the shared secret. This is the password used between the WLC and the radius server. It is not for users. Click Apply. After clicking Apply, the list is configured. Radius authentication servers refreshes with the new server listed.